recording? All right, now we are recording. All right, let's take a look, and we're going to do the first section of the book. I don't know what page it's on. Somebody look and tell me where it starts. It's actually a review, and it's R.1 is what they call it. R.1. It's review 1 is basically what it is. Man, I need a little light up here because let me make sure. Oh, I got it. There we go. Now we're rolling. Now, today's lesson and tomorrow's lesson, well, maybe the next several lessons, are pretty basic stuff. All right, and I debated on skipping them or not. But I thought I would just go through it. It's in the book. I should have talked to Mr. Rao to see if he did this or not. But that's what we got. All right, so let's start off. Again, we're doing like pre-algebra stuff right here at the beginning. So bear with me. It should be pretty easy for you. So let's take a look at this word right here. Okay, can everybody see that all right? All right, let's talk about the word difference. Okay, in math, what does the word difference basically mean? Give me one word. Thank you. Subtract. Okay, so that's what it is. So if we did something like this, if we did 8 minus 5, we're going back to, I don't know when you do this, first grade maybe, something like that. Okay, 8 minus 5, that's pretty easy. But if we do it kind of algebraically and use our subtraction rules or our addition rules and stuff, basically it's like this. It's 8 plus negative 5. Would you agree with that? Yeah. Do you remember the rule for addition with different signs? Like if you have different signs, I could go, I'm not going to sit here and like write all the rules out, but I'm just going to show you some examples of them. So if you're adding two numbers together, you add the two numbers together and you keep the sign of the largest number. Do you remember that? Okay, so that's what we do. So if you, I didn't say that right. Add them together. Oh, okay. Again, sorry, it's been a while. It's been 9 years since I've done this. So what I usually do is this. For a subtraction, when I say, instead of subtract, I say add the opposite. Hopefully my handwriting on this tablet will get a little bit better. I'm just not used to writing on this thing, so bear with me. So if I add the opposite, what I do, instead of 8 minus 5, I turn it into a plus. That's the add part. And then the opposite. What's the opposite of positive 5? It's negative 5. Okay, and my rules say that I subtract the two numbers and take the sign of the largest. Remember that? So if I subtract them, 8 minus 5 is 3. What's the sign of the larger number of these two? It's positive. So what's the sign of this? It's positive. Pretty simple, okay? Couldn't get much easier. You're like, your parents say, what'd you learn today in your math class? Well, we learned how to do 8 minus 5. And they'll probably yank you out of the school because you're not learning enough. But it'll get harder, I promise. So let's do another one. What if I do something like this? 4 minus 9. This is where they don't do this in first grade, okay? They start this probably in middle school or something like that. It may be pre-algebra or something like that, because if you have 4 things, if I have 4 things and I take away 9 from it, a kid, that'll blow a kid's mind, right? Like, how can you take 9 away from 4? You can't do it, okay? But if you think of money, right? If Mac owes me $9, but he only gives me 4, he still owes me how much? $5, okay? So that's kind of like the negative, right? If he owes me money. You follow me on that? That's what we're doing here. So 4 minus 9, what do? We add the opposite, subtract the two numbers. So 9 minus 4 is 5. Take the sign of the larger number, which is negative, and so your answer is negative 5. So that is difference. Wow, that was pretty easy. Let's do another word, and it's called quotient. Let me scooch this up a little bit. There we go. All right, and it's called quotient. Somebody tell me what quotient means in math. It's supposed to be an I. It's division, correct. All right, so let's take a look at that. And here's the example they give. If you have a number divided by another number, it's the same thing as this. It's the same thing as taking the top. What do we call the top and bottom of a fraction? The top is called the what? The numerator, and the bottom is denominator. Okay, so we take the numerator and we multiply it. Instead of division, division is basically multiplication. Just like subtraction is basically addition, just like I showed you before. So division is basically multiplication. But we're not multiplying by b. What are we multiplying by? 1 over b. Everybody, you understand that? So if I went the other way, a times 1 is a, and then this is kind of like over 1, isn't it? So it's a over b. And that's the same exact thing? Yeah. It's a real basic principle, but let's keep going. Let's do multiplication. Multiplication by 0. All right, so everybody should know this. So if I take a number, a stands for any number. If I multiply it by 0, what do I always get? I get 0. That's multiplication by 0. Pretty simple. What about division by 0? So division, I'll just shorthand it, division by 0. Now, there's two situations. You might have 0 divided by a. What's 0 divided by anything? It's 0. You can put it in your calculator and give it a shot, okay? 0 divided by anything. Do you remember how to check? Let's go back in time a little bit to elementary school. Let's say you had 12 divided by 3. What's 12 divided by 3? It's 4. Do you remember how to check it? Yeah, multiply this one times this one, all right? So 4 times 3, and it should equal the numerator. Does it? Yeah, so it's right, okay? So you remember that, right? Elementary school doing that kind of thing. Well, let's do the same thing with this. 0 times a should equal what? 0, does it? Yeah, 0 times anything is 0. We just said it right here. So that's division by 0. Well, we have two situations here. We have 0 divided by a number. What if we had a number divided by 0? So I'm going to put a blank right here and a question mark. So what number multiplied by 0 is going to give you a? There is nothing, is there? Because if I multiply any number by 0, what's my answer always have to be? It's got to be 0. So this cannot exist. Would you agree? There is no number that exists that if I multiply by 0, I'm going to get a certain number, except for 0, right? So this does not exist, all right? It's undefined, is what we say. Everybody with me on that? All right. Again, I told you this was easy, didn't I? You think it's always going to be this easy? Yeah, probably not. Okay. Let's take a look at some rules of some signs for multiplication. Some rules for multiplication. And again, I'm going to try to go through this quick. If you have a positive number times a negative number, we could rewrite this. We could just put, you could write it a couple ways, really. If you wanted to, you could write it like that. Would that be the exact same thing? Yep. Or you could do this. You could put the AB in here and put a negative out in front. That's really the same thing, right? All this is going to come back eventually. Okay, we're gonna hit portions of this eventually in a much more complicated manner. But we just got to go over the basics right now. Man, this stuff's just way too easy. Let me just go right to the examples instead of doing all this A and B stuff. If you want to look in the book, it's right there in the book. Okay. Oh, by the way, speaking of the book, there is an online version of the book, but the problem is it's not the same edition as the book that we have in front of us. Okay. I found a 9th and 10th edition, and I can't get the 8th edition. So it's the same stuff, but the problems are in a different order. I think they're pretty much the same problems, but they're in a different order. So anyway, if you want to see the topics and you forgot to bring your book home or something, you can go on the online version. I'll put a link. There's a PDF to it. I haven't set up Teams yet, but I will set up Teams and put it in the files. You guys did that last year, right? Go to files and find stuff. So I'll put the book in there. I haven't done it yet. Give me a day or two, and then I'll put it in there. So if you need a book at home, again, it's not the exact same problems, but it's close. Like number 5 in the book in front of you might be number 7 in the online book or something. Okay, but at least you can look at the book itself to see the examples and all that kind of stuff. All right, let's just do a couple examples. That's supposed to be a 2. Sorry. What if we have this? If we have multiplication, you got two different signs. What's the rule if you have two different signs right here? Yeah, it's always negative, okay? When you multiply two numbers together and they're different signs, the answer is always negative. So it's -6, all right? Pretty simple. What if you have the same sign? Yeah, if you multiply and you have two numbers that have the exact same sign, it doesn't matter if they're both positive or both negative, the answer is always positive, all right? You know that before. Okay, here's something that tricks people up a little bit. What if you had something like that? Now, you can't really reduce that. Okay, we're not going to make it 1.5. Don't worry about that. But this is the same as this. It doesn't matter where the negative is. Because remember, if you multiply or divide a positive and a negative, two different signs, your answer is always going to be negative. You follow me on that? Or you could write it like this. You could put it out in front of the little fraction bar thing. And you can do that. So all three of these things are exactly the same. Again, this is super simple principle, but later on it's going to be more complicated, and just knowing these easy principles is going to help you out a little bit. All right, and obviously if you have two negatives, it's the same as multiplication. Division and multiplication have the same rules with signs. So if you have the same sign, it's always positive, so it would just be positive 4/9. All right, enough of that. Let's keep going. What else we got? Oh, let's do this. All right. Getting tired of yellow, are you? Let's try this light blue. See what that looks like. All righty, let's do this. If I have A times C equals B times C. All right, let's just stick some numbers in here. Let's call A 3, and let's call B 2, and let's call C 4. Nope, let's not do that. That was dumb. Let's say A and B are the same. Oh, what did I do there? There we go. Let's say, oh, forget that. Forget it. I was just trying to do this off the top of my head. I should stick to my notes, shouldn't I? Yeah, let's just do this. Let's say that we have the same number here and the same number here. Okay, the C and the C are the exact same number. Sorry, I'm just trying to think of something that I want to do, but I'll just stick with this. If I wanted to get rid of the C, do you remember how to do that? If you have two things that are multiplied, how do we get rid of something? We divide, okay? Or a lot of times we call it what? What happens when we do this? Give me a phrase that we use in math all the time. What do we say those C's do? They cancel out, right? They cancel out. And that's okay. I don't mind you say cancel out, but I want you to understand what's really happening. And again, in the future, this is going to be way more complicated. But we cross them out or they cancel each other out, but they're really dividing themselves out. If we divide one side by something, we have to divide the other side by the same thing, okay? And then we're left with A equals B. That's basically what they're just trying to teach you right there. Not that big of a deal. So here's super easy pre-algebra kind of stuff. If I have something like this and I ask you to solve for x, what do? Well, I get rid of the 2 by dividing by a 2, get rid of this. Okay, I got to do it on the same side. As long as I do the same thing on both sides, I'm good to go. Here's what the principle is. The 2's cancel out, right? Or they divide out. Because really, what's 2 divided by 2? It's 1, isn't it? 1 times x is x. That's why they cancel out. We get so used to saying cancel all the time, we don't really realize what's going on. And right here is 3, so x is equal to 3. All right? Oh, let's see what else I want to do. I got so much. All right, let's do this. Here's a different topic altogether, kind of. It says if AB equals 0. This is super important. We're going to do stuff, and you did in algebra too, where you set things equal to 0. This is like the very, very basics of something that can get pretty complicated in the future, all right? But this is the basics of it. And maybe we'll refer back to day 1 when we did this. If A times B is equal to 0, tell me something about A or something about B or something about both of them. What do you think? Somebody tell me. One of them's got to be a 0. Would you agree? If I have something that multiplies to be 0, one of those has to be a 0. It can't be anything else. So either the A has to be 0, B has to be 0, or what? Both of them have to be 0. We didn't quite get to everything, but this is really simple. So here's your homework. It's section R1. It's page... Oh, I didn't put what page it's on. I forget what page it's on. But anyway, you'll see the numbers. I forget what page it's on. You can find it, and it's numbers. Now, this looks like a lot, but don't get freaked out because you're only going to do the odds. Okay? And they're all super easy. They probably take like 2 seconds each to do these. Okay? Everybody got it? There it is right there. 49 to 97. You're just doing the odds, though. You're just doing the odds. And guess what? Guess where the odds are? The answers are in the back. The odd answers are in the back. But you must show your work. Okay? You got to write down the problem just like this. Okay? If the problem was that easy, whoops. I want you to, why is this doing that? I want you to write it down just like that. All right. That's it. We'll see you guys.